Greetings everyone. Today we're going to discuss the fourth question which was asked by the LeetCode, the minimum time to complete all tasks. Let's just read the question quickly. There is a computer that can run the unlimited number of tasks at the same time, right? And you are given a 2D integer array, the task and a task where a task of I is equal to start of I, end of I and duration of I. Indicate that the ith task should be run total of duration of I second, not necessarily continuously. Okay. So within the inclusive time range, start of I and end of I. You may turn off the computer on turn on the computer only when it is needed to run the task, and you can turn off when it is ideal. Return the minimum duration which the computer should be turned on to complete all the tasks. So basically we have to tell the minimum duration till our machine should run to complete all the tasks, and task will run from the start of I till end of I, inclusive, both inclusive, right? And the total duration is duration of I. So the solution which I'm gonna present is a greedy solution, and the basic intuition behind this solution is that we will do the work as late as possible to increase the maximum chance of overlapping, right? So to increase the maximum chance of overlapping. So let us walk through the code for the better understanding, right? Okay. Right. So here's the solution. Um, Here I have declared a variable vector called check, and it will store the. We know that the maximum value will vary from the 1 to 2000. So I have declared the check variable from the for 2002 size, and default value is 0. Basically, the check vector will tell us whether our machine is running at ith indexing or not. If it is running, then it is will be true, else it will false. And I have shorted the task vector such that in such order that the in or in such order that the task which will be completed, which has the more headroom, will be at the towards the end, and which has the less headroom will be towards the starting, basically in the ascending order of the end of I, as per the ascending order of the end of I, right? And then I have just run this simple for loop, and what I have done here, that I have extracted the starting point of the our element, ending point of our element, and total duration. And I have subtracted what I have subtracted is like the total time till which the machine is already running in our given range. And if our d is still greater than 0, means the total machine was not running for the certain number of times, then what I have done is that I have I have turned on the bit towards from the end, and I subtracted the value from the d. Let us see this one sample test case for the better understanding of this code, right? The first sample test case was 231451152. Okay, so the first step was that the check variable, where I have already defined this check variable, and it is of size 200, but I have just make this still 10. It will be sufficient for this example. And and the default value of the all the will be 0. Now we have sorted the our task value. So after sorting, it will be look like something like this, like 2 3 1, then it will be 1 5 2, and then it will be like 4 5, and now our code will start running, right? The first st of t of 0, t of 1 and t of 2 will be get extracted, and then the st will be what? The st will be 2, end will be 3, and d will be equal to 1. So the already running function will check from the 2 to 3 how many indexing between 2 to 3 are there where the machine is already running. So the initial state is 0, 0 all 0, so it will return the 0. So after this line our value of d will be remain 1. Now this for loop will run and it will subtract those value from, it will make the machine on those value from the end where the machine was not already on and subtract the value from the d. So this will start from the 3, right, and run till the d is greater than 0 by decreasing 1. So what will check that whether our bit was on at 3 or not. So as we can see it's not on, so it will subtract the value from the d. So our d will become what? Our d will become 0 and the bit will be at the position 3 will be now 1, right? And since d is 0, then it will break the loop. Now loop will move forward and now 1 comma 5 will come, then the value of start will be 1, end will be 5 and d will be 2. Right. So again this already running function will return from the 1 to 5 how many indexing are true. So here the only one indexing is 2, which is at 3. So after this step the value of 2 will now become what? 2 will now is 1, 2 is now 1, and now this for loop will run from the 5 till the d is greater than 0. It will check whether the 5 is on or off in the already running vector. It is off, so it will on this bit and subtract the value from the d. Now d is what? The d is 0 and our loop will get terminated, right? So now the 4 comma 5 will come as the loop move forward. Now it's turned for 4 comma 5, so start will be 4, end will be 5 and duration will be 1. So again already running will check from the 4 to 5 how many values at how many indexing our bits are on. So as we can see at 5 it is on, and from 4 to 5 only the one at one position the bit is on, so it will return the 1 and the value of d will be 0. So our for loop will not run and we will reach to the end of the loop, so it will come out of this for loop, and at the end of the program I have returned the number of bits which are on in our check array, because the check array was basically storing that till how many hours or till how many times from the 0 to 2002 our machine will run. So at final it will give that our machine will run for 2 instance, the 3 and 5, and so the answer will be 2. So this was the approach. This was the basically a greedy solution, and the key takeaway from this was key observation was that we have to arrange the number, or we have to complete the task towards the end to increase the maximum chance of overlapping. And if the machine is already running, then just subtract the value from the d, and if it is not running, then initiate the values or on the machine towards the end of the end of the task and subtract the value, and at the end return the count of all the values where the machines was already on, right? Your machine is running. So yeah, this was the whole solution. I hope you got the solution, and if you have any doubt, then feel free to ask in the chat sections of the and the comment section. Yeah, thank you. And yeah, complexity of this code was O of n square, as the already running function is running for entire range from the start to end. In worst case it will be run for O of n, and for task is also running for the O of n times, so the overall complexity of this code will be big O of n square, and space complexity will be big O of n. Space complexity of this question is big O of n. Yeah, this was all from my side. Thank you and have a nice day.